children, welcome back. The chapter that we are dealing now is real numbers. This is part 2. Hope you have done the questions related to this chapter, which I have shared in part 1. So I had taught you how to find the LCM and HCF using prime factorization method, and we also learned the fundamental theorem of arithmetic. Now in this we will do some application problems related to HCF and LCM. Now when a question is given, first you have to identify whether you have to find HCF or LCM. Find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. So some number has to be divided by 520 and 468. The smallest number which is divisible by. That means you need a number in the numerator. That number is going to be divided by 520 and 460. So that means you have to find a the numerator. So it is LCM. So numerator, so you can remember like this. So this is one way of identifying whether it is HCF or LCM. Numerator you have to find, so you have to go for, because numerator is always a higher number means it is multiple. If it is lower number, then we will be doing HCF. So we will find the LCM of 520 and 468. So the prime factorization method, when you factorize it, you will get, so you have to write it as product of primes. Remember that? So from this now we will write the LCM. So what did we say? For LCM you have to consider all the factors. So it is 2 cube and 2 squared. So we will take 2 cube. Then 3 squared is not there in 520, but still you should take 3 squared. Then 5 into 30. So when you multiply this, you will get 4680. Now this is not the answer because you have found the LCM. So LCM 4680 divided by 520, it will be exactly divisible. And again 4680 divided by 468 is exactly divisible. But you need a smallest number which when increased by 17 is divisible by this. So that means a number plus 17 is divisible. Divisible means then it is LCM. So x plus 17 equal to LCM. So the required number will be LCM minus 17. So LCM is 4680 minus 17 equal to 4663 is the required answer. The next question. What is the smallest number that when divided by 35, 56 and 91 leaves remainder of 7 in each case? So first we will find the prime factorization. The smallest number when divided by these numbers. So you have to find the numerator. So then therefore it is, you have to find the LCM. So we will first find the LCM of 35, 56 and 91. So we will write 2 cube into 5 into 7 into 13. 2 cube into 5, 7 and then 13. When you multiply, you will get this as 3640. So now how will you proceed? The smallest number when divided by this leaves a remainder of 7. So this is completely divisible by these numbers, but you should get a remainder of 7. So you have to add LCM plus 7. So 3647 is the required answer. So when you are dividing 3647 by 35, you will get 7 as a remainder. Similarly, all the numbers. So because 3640 is completely divisible, but you need a remainder, means you should add that number to the LCM. The next question. Find the largest positive integer that will divide 398, 436 and 542, leaving remainders of 7, 11 and 15. Now here the remainders are different, and you have to find the largest positive integer that will divide 398. So some number has to divide 398, 436 and 542. That means it is a denominator. So when you have to find the denominator, you have to go for factor is the smaller number. So you will find HCF. So you will find the HCF of 398, 436 and 542. Sorry, you will not find the HCF 398. You will have to subtract the remainders. Subtract the remainders from the respective numbers. So you have to find the HCF of 398 minus 7, 391, 436 minus 11, that's 425, and 542 minus 15, that's 527. So we will do the prime factorization. 391 will be 17 into 23, 425 is 5 squared into 17, and 527 is equal to 17 into 31. Now HCF is equal to, you have to find which is common in all the three. So the common in all the three is only 17. So HCF is 17. For checking, so this is the required answer. For checking, you see 398, because you need remainders of 7. 398 divided by 17, you see, you will get a remainder of 7. For 436, again you divide by 17 and check, you will get 11 as a remainder. And similarly for 542, you will get 15 as a remainder. So here you have to first, when you are seeing this HCF, first you have to subtract the remainders, and then you have to find the common factor. On a walk, 3 persons start together. Their step measures 40, 42, 45 centimeters respectively. What is the minimum distance each should walk so that each can cover the same distance and complete steps? So that means each person's speed is different. 40, 42, they will complete in one step. They will complete 40 centimeters, 42 centimeters and 45 centimeters. At some point, so A will be walking, the first person is walking to some distance. Suppose this is the distance, same, where A would have completely covered that 40, 40, 40 steps. They would have covered this distance completely. The same distance covered by B, 42 centimeters, this 40 centimeters and 42 centimeters and 45 centimeters. So they, at some a particular distance, they would have completed that steps. So we have to find that distance where all 4 would have completely finished that step. So you have to find a higher number. So that means you have to go for LCM. So LCM of, so that's how you will identify whether you have to find LCM or HCF. So LCM of 40, 42 and 45, you will find the prime factorization. whichever method is comfortable for you, you can use that. 2 into 3 into 7 and 3 squared into 5. So L for LCM, you have to consider all the factors. So 2 cube and 2, so 2 cube we have to take. Then 3 and 3 squared, so 3 square. Then 5 and 7. So equal to 2520 centimeters. So at this, so this length will be 2520. Number of steps if they had asked, then you have to divide 2520 divided by 40, 2520 divided by 42, 2520 divided by 45, etc. Then you will get the number of steps. So number of steps each would have covered will be 2520 by 40, it will be 63, 2520 LCM divided by 42, 60 steps, and the third person, he would have taken 56 steps, so that they cover the same distance and complete steps. The next question, what is the greatest number of 6 digits exactly divisible by 24, 15 and 36? So let us identify whether it is HCF or LCM. So a greatest 6-digit number should be divisible by 24, 15 and 36. So a number has to be divided by these. That means the numerator. So numerator, hence it is LCM. So we will find the LCM of 24, 15 and 36. So I have done the prime factorization here. So LCM will be equal to 2 cube into 3 square. Into, any other factor is there? Yes, 5 is there. So 2 cube, 3 squared and 5. This is equal to 360 is the LCM. Now they have asked what is the greatest number of 6 digits. So 360 is the least common multiple, but we need a 6-digit number. So you have to keep on multiplying 360 into 2, 360 into 3, 360 into 4. So that is a cumbersome process. So we will do a different method. So write down the greatest 6-digit number and divide it by 360. So you will get 279 as the remainder. So if you subtract 279 from this, that number will be divisible by 360. So for example, suppose you are dividing 24 by 5. So you will get a remainder of 4. So if this 24 is completely divisible, to make 24 completely divisible by 5, you have to subtract 4 from 24, so it becomes 20. So 20 will be completely divisible by 5. The same concept we are using here. You subtract 279 from this number, so that number will be completely divisible by 360. So the required number is 999 minus 279. So it is 7999. So this is the required number. This is the required number. Now a man wants to plant 66 apple trees, 110 mangoes and 88 banana trees in equal rows. Also he wants to make distinct rows of trees, that is each type of tree in each row. Find the number of minimum rows required. So many trees are there. Now when you are you have to plant it in different rows. So you need a very few rows, isn't it? So you have to find you need a smaller number only. Then that's why you have to go for HCF. Number of rows, smaller number. So you have to go for HCF. So now you slowly will understand how to identify whether it is HCF or LCM. Now we will find the HCF of 66, 110 and 88. So if you 60, 66. So 66 is equal to 11 into 6. 110 is equal to 11 into 10, or you can say 2 into 5 into 11, and 88 is 11 into 8. 8 is 2 cube. 2 cube into 11. So your HCF will be 2 is not common. So okay, 2 is common. 2 into 3. So 2 is common. So 2 into, then 3 is not common. 5 is not common. Only 11 is common. So 11. So HCF is equal to 22. So number of trees in each row will be 22. Now you have to find the number of minimum rows. So number of rows of apple trees equal to what? Number of apple trees are 66. So 66 divided by 22 will have 3 rows. Similarly for mango, 110 divided by 22 equal to 5, and banana 88. Sorry. 88 divided by 22 equal to 4 rows. So total rows 3 plus 5 plus 4 equal to 12. So read the question properly, carefully, and then accordingly decide what to do. Suppose they had asked you only to find the number of trees in each row, then you have to do only this one. But they have asked you to find the minimum rows required. So you have to go for this. So what you got, HCF 22 is not the rows, it is a number of trees, because we are taking 66 apple trees, mango trees and banana trees. We are finding the HCF. So what you are getting is the number of trees. Hope it's clear. Now this is slightly different question. A circular field circumference is given as 360 kilometers, and three cyclists are cycling round the field. Per day they are covering 48, 60 and 72 kilometers. When will they meet again? That is, in how many days they are going to meet. So if you take, so it is again a higher number that you need, so you have to go for LCM. So that is clear now. But when you take LCM of this, you will get kilometers. But now we want how many days. So for that, we will convert this number of days each cyclist takes to complete one round. So 48 kilometers per day the first person is cycling. So in 360 divided by 48, he will take 7.5, 7.5 days to complete one round. Similarly, you find, so for all the three, we'll get 7.5, 6 and 5. Now if you take the LCM of this, this is in decimal, so we will convert it into hours, and then we will find the LCM. So LCM of 180, 144 and 120 you have to find. So a prime factorization I have already done. Now we will find the factors that we have to include. So 2, you have to take 2 to the power of 4, the highest exponent. Then 3 square, and then 5. So you will get this as 720. Hours you will get. So this convert it into days. 720 divided by 24, you will get 30 days. So the cyclists will meet. They will meet after 30 days. Find the greatest number of 5 digits that will give a remainder of 5 when divided by 8 and 9 respectively. So you have to find the numerator. So that means you have to go for LCM. So numerator, so LCM. Now a number which has to be divided by 8 and 9. So you have to find the LCM of 8 and 9. So 8 and 9 LCM will be 72. Now we will divide the greatest 5 digit number by 72. So you will get a remainder of 63. So as I told earlier, 9 this number 99999 is not completely divisible by 72. You are getting a remainder of 63. So the greatest number divisible by 8 and 9 will be equal to, you have to subtract 63 from this. But this is not what you need. They have asked you to find a number that will give a remainder of 5. So this number, when you divide by 72, you will not get any remainder. So to get the remainder, you have to add 5 to this number. So the required number will be plus 5. So the required number will be 99941. So you have to practice these sums many times and try to understand the concept, because by hearting you will make 100%, you will make mistakes. So try to understand the concept, and as you know, maths is fun only if you practice it. So see you again with more questions in my next video. Till then, have a great day.